This is Henry, and I'm going to be teaching you Standard 7, which involves finding the exact values of trigonometric ratios for each angle on the unit circle. So our first problem is going to consist of sine 11 pi all over 6 all the way to cotangent 11 pi over 6, and we're trying to find the exact value of each of these trigonometric ratios, total of 6. So first, we're going to refer to our unit circle here. So we're going to find 11 pi over 6. There it is. All right, and when using the unit circle, forgive me, the x value of the point is always the cosine, while as the y value of the point is always the sine. So in this case, the cosine of 11 pi over 6 is root 3 over 2, and the sine is negative 1/2. So let's write that down up here. Alright, so here's where it gets a little bit more complicated. Now, I've already worked this out, but I'm going to take you step by step in it. So tangent is sine all over cosine. Alright, and to do this problem, we're going to flip and multiply. So we're going to flip the bottom. We have 2 all over root 3 times negative 1/2. Alright, then we're going to get on top negative 2, and on bottom 2 times root 3. Alright, the 2 and the 2 cancel out. After that, you're left with 1 on top and a root 3, and it's negative, so it's negative 1 all over root 3. Now, we can't leave the radical in the bottom, so we multiply by root 3 on top and bottom. So in the end, you get root 3 all over 3, negative root 3 all over 3, excuse me, because you have to carry down the negative constantly, as our tangent of 11 pi over 6. So we're going to write that in. Alright, so next, let's tackle the cosecant of 11 pi over 6. So now, when referring to cosecant and secant, cosecant is 1 all over sine, secant is 1 all over cosine. So we're going to start with 1 all over sine with cosecant. So our sine is negative 1/2. So we have 1 all over negative 1/2. Again, we're going to flip and multiply. That's basically what it comes down to when doing this. After doing that, you get negative 2, because it's a simple negative 2 all over 1 times 1 is negative 2. Alright, so let's write that in as the cosecant. Alright, so now we're going to find the secant. So again, 1 all over cosine. So we're going to go 1 all over root 3 all over 2. Flip and multiply here again. After getting this, we again get the 2 all over root 3, so we have to multiply by root 3 on both top and bottom. After doing that, these two will cancel out, and whenever doing that, it's basically squaring the radical. So when you square the radical, it gets rid of the radical, and you're just left with 3. So, and then you multiply the top, which in the end ends up to be 2 times root 3 all over 3. So that is our secant value. Alright, so next we have cotangent. Cotangent is essentially the opposite of tangent. So cotangent is cosine all over sine, while as tangent is sine all over cosine. If you haven't memorized these essentially you really need to get on that. Alright, and same goes with the unit circle. To understand this standard, you need to memorize both of those to fully grasp it. So back to cotangent here. So we have the cosine, which is root 3 over 2, all over the sine, which is negative 1/2. Alright, we're going to flip and multiply, like we did in the previous steps. So once we flip and multiply, we get negative 2 times root 3 all over 2. Of course, we cancel out the 2's, and we're just left with negative root 3. So then we write in negative root 3. And that's how you find the exact values. So next, we're going to try one of the problems, the other types of problems that we're going to encounter. So you're going to get a whole bunch of these different sine pi over 3, sine 7 pi over 6, plus cosine of 330 degrees. It's going to look like, oh god, I can't do this. But in reality, we're just going to refer back to the unit circle here and just reduce all of these using it. Okay, so first we're going to find the tangent of 7 pi over 6. So using what we learned in our last step, we go to 7 pi over 6. We have negative root 3 all over 2 and negative 1/2. Now again, tangent is sine all over cosine. So we're going to write negative 1/2 all over negative root 3 all over 2. Again, we just do the simple flip and multiply. Negative 1/2 times 2 all over root 3. Okay, and this probably looks familiar from the last problem. We worked on very similar to this. So we do this, we get our, both of these are negative. So we multiply the 2, it becomes a positive. So we have a 2 all over 2 root 3. Okay, we cancel out the 2's again. We have 1 all over root 3. Okay, again, we can't leave the radical in the bottom, so we multiply by root 3, both top and bottom. Alright, and from there, you get root 3 all over 3. So that's our value for this one. Now, these are much simpler because they're sines and cosines, which we can directly refer to the unit circle with. So now that we have our root 3 all over 3, we multiply. Let's find sine pi over 3. There's pi over 3, and the sine is the second, or the y of that. So we have root 3 all over 2. So we have root 3 all over 2 divided by the sine of 7 pi over 6, where we were before, which is negative 1/2. Alright, and then we're going to add the cosine of 330. Now, you see, the radians and the degrees here are interchangeable. So the angle 330 degrees is the same essentially as 11 pi over 6 radians. So again, you just refer down to here. The cosine, which is the first value, of course, is root 3 all over 2. So we put root 3 over 2. Alright, so because these are in parentheses, we need to, again, we need to finish this before we add this together and then multiply. So we'll flip and multiply. We have root 3 all over 2 times negative 2 all over 1. So in this case we get negative 2 root 3 all over 2. Cross those out, left with a negative root 3 plus root 3 all over 2. Again, just taking that one up there. We do that, and then you multiply by root 3 all over 3 there. Alright, and then when we go ahead and add these two together, put this all over 1, we want to find the value, essentially the best, we want to find a common denominator, sorry. So we put 2 up here all over 2 plus root 3 all over 2. So we have those, and root 3 all over 3 again. So then, then we add these two together. We're left with a negative 3 root 3 all over 2 times root 3 all over 3. So when we multiply these two out, we're going to be, again, it's just squaring it. So we're going to be left with just a negative 3. Then when we multiply the bottom, we're left with 6. Negative 3 all over 6 will go to negative 1/2. Alright, so today we're going to find out the sine and cosine and cotangent, secant, cosecant, and tangent values of 11 pi over 4. These are the exact values of these 6 trigonometric ratios. Alright, so let's move over to our unit circle here. So we're going to try and find 11 pi over 4. So as you notice, there is no 11 pi over 4 that's generically written here. But when we do it, we essentially are just adding on each time. As you can see, 2, 2, 2. So from here to here, that's 9 pi all over 4. From here to here, that's 11 pi over 4. See, because each time we go around, it's essentially adding 2 pi to that top one here. So you just look for those patterns when you're faced with something that's not directly on the unit circle, like that. So now that I've found 11 pi all over 4, we again look at the x is the cosine value, the y is the sine value. So the sine is root 2 all over 2. The cosine is negative root 2 all over 2. Okay, so now we are going to find the cotangent value. So we first put essentially cosine over sine, which is negative root 2 all over 2 all over root 2 all over 2. That's pretty simple. You just get negative 1 because it's 1. And so then next we're going to find secant, which is 1 all over cosine. So 1 all over negative root 2 all over 2. We're going to flip and multiply them, and we get 1 times negative 2 all over root 2. So after we multiply this, we just get the negative 2 all over root 2. Now we can't leave the radical on the bottom, so we multiply by root 2 on both there. So then we get negative 2 times root 2 all over 2. Cross those out, and the secant value is negative root 2. Because those two just cross out right there. Alright, so next, cosecant value, which is 1 all over sine. So it's essentially the same thing as our previous secant, except there's no negative. So we go through the same steps, multiplying by the radicals again. Get the 2 times root 2 all over 2. 2's cross out, and you just get root 2. Alright, now we're going to find the tangent. So we've already done the cotangent, so this is honestly pretty easy from here. So now we're just going to put the sine all over the cosine, which is root 2 all over 2 all over negative root 2 all over 2. They're the same number, so it's just negative 1, same as cotangent. Alright, now we have again our second type of problem here. We have the cosine pi over 6 all over the sine of 5 pi over 3 plus the tangent of 5 pi all over 4. Now we're going to simplify this and leave it in exact form in our answer. So we're going to come over to our unit circle. We're going to find pi over 6. There's pi over 6. Alright, and now we're going to find the cosine value. Again, the cosine is the x value, sine is the y value, so we're looking for the cosine. So that is root 3 all over 2. Okay, so we put the root 3 all over 2 here, all over the sine of 5 pi over 3. Let's go around the unit circle. There's 5 pi over 3. Now we need the sine value, which is the y value here. So we get negative root 3 all over 2. Now this first one comes out quite nicely, because when we have this same number all over each other, it just simplifies to be 1. But we have this negative here, so we have to remember it's -1 here. Alright, now we need to find out how to get the tangent of 5 pi all over 4. So let's find 5 pi over 4. There it is. Alright, and sine all over cosine. So the sine of it is √2, negative √2 all over 2, all over negative √2 all over 2. Alright, so we get that. Again, real simple. The negatives cancel out. So does that. And we're just left with 1. -1 plus 1 equals 0. 0 is our final answer.